The objective of this video is to solve literal equations for a specified variable. Now, a literal equation is an equation that has more than one variable. And you're going to be asked to solve for one or the other variables in there. That's what the whole objective here is, to learn how to do that. Now, it's assumed that you already know how to solve equations, and that this is just an extra step of solving equations with more than one variable. Here are some examples of equations that have more than one variable. Some of them you may have seen, some of them you may not have seen. There's a lot of equations out there that have more than one variable. A lot of equations that have to deal with science and math and all sorts of things, even the economy. Lots of equations out there that have more than one variable. And many times you're going to be given one part of it but not another, or you may be given the other part, not the other. You need to be able to solve a literal equation for one of those variables, so that you can plug in the information you've got and get an answer like that. And to do that, you often need spreadsheets. And the spreadsheets are not going to solve the equations for you. You have to figure out how to plug the equations in properly. To solve literal equations, you use the same procedure as you use for solving equations. You're going to use the reverse order of operations, and you're going to use opposite operations. Your answers will not be a simple number. You're not going to get x equals 12. You're going to get x equals y to the second power 5 divided by 2 times 87 plus z minus 8. There's going to be all sorts of weird, odd stuff going on there. Your answer is not going to be a simple number. So be prepared for that. We're going to go through solving several different formulas, some formulas that will pop up as being these literal equations. You might see them on standardized tests, you might see them in science class. So I figured just go through several of these. Starting off with the formula for the perimeter of a rectangle. P equals 2w plus 2l, 2 times the width plus 2 times the length. This time we're asked to solve for the width. To do that, we want to get the w all alone. Whenever you're solving for a variable, it means you want to isolate that variable. You want to get that variable equals something. So you've got to ask yourself, what's being done to the w right now? Well, it's got the 2 times it, and it's got this plus 2l. So according to the order of operations, if I had values here, I would be multiplying by 2 and then adding this 2l here. We need to do the opposite operations to solve, and in the opposite order. So instead of finishing off by adding 2l, I'm going to start off by subtracting 2l from both sides. When I do that, the 2l's will cancel out. P minus 2l is going to be P minus 2l. You can't subtract 2l from P. It stays like that. This side becomes 2w. W is not alone yet. It's got that times 2 there. We have to do the opposite of multiply, which is divide. So we divide by 2, and we get P minus 2l over 2 is equal to w. Now, in my class, I would find that as acceptable as an answer. You may be asked to step further here and see that you can simplify this just a little bit. If you break this up into P over 2 minus 2L over 2, you can actually simplify the 2's here, and you would get W is equal to P over 2 minus L. So this might be the answer you see. This might be the answer you see. In my class, I'd be fine with that being left as your answer. Who hasn't heard of E equals mc squared? That's the formula for energy that Einstein came up with. This time we're asked to solve for C. Maybe we want to know what the speed of light is if we're given mass and energy. It's kind of silly here, but let's see what happens here. To solve for c, we first have to get rid of the m. So we're starting off with e equals mc squared. We need to get rid of the m, that's m times c squared. So it means I've got to divide by m. And that's going to give me e over m is equal to c squared. The square is still there. I've got to get rid of the square. The opposite of squaring is the square root. So we do the square root to get rid of the square. That makes this side c. This side stays as a square root of e over m. That's solved for c. Now, Mr. Funk, the c's on the wrong side. It's okay. It's okay to have your c over here. Once you got the variable alone, it doesn't matter which side is on as long as the variable is all alone. Because this is the same as saying c equals the square root of e over m. Both of these are the same thing. So it doesn't matter which side of the equation your variable ends up on, as long as it's alone. I want to be alone. All right, moving on. Here we have the area for the circumference of a circle, 2 pi r, and we're asked to solve for r. There are two variables here. Somebody will, well, pi is not a variable. Yeah, pi is not a variable, but many times it's left as pi in a formula because it's not an exact number. You may need to round to different numbers depending on how exact you want to be with your information. But there are two variables, r and c, so it does qualify as a literal equation. All right, here we go. We got c equals 2 pi r. R is being multiplied by 2 and pi. So to get rid of the 2 and pi, I go to the opposite, which is divide by 2 pi. Because 2 pi over 2 pi is going to cancel out. You'll end up with 1 times r, which is r. But in order to do that, whatever you do to one side, you have to do the same thing to the other side of the equation. So you end up with c over 2 pi is equal to r. Area of a square is pi r squared. This time we're asked to solve for r. So we start off with a equals pi r squared. We're multiplying by pi, we need to divide by pi to get rid of it. That gives me a over pi is equal to r squared. Again, we have to do the square root to get rid of a square. So we end up with the square root of a over pi is equal to the radius. Area equals 1/2 base times height. That's the formula for the area of a triangle. Let's say we're asked to solve for the base on that one, which means we want b to be alone. So we have a equals 1/2 base times height. I'd like to get rid of that half first. And that is 1/2 times b, which means I should technically be dividing by a half. But you never divide by a fraction. Instead, you multiply by its reciprocal. Because that's going to give me 1 times 2 is 2. 2 times 1 is 2. So I get 2 over 2, which is 1. 1 times BH is just plain BH. Now, whatever I do to one side, I have to do the same thing to the other. This ends up giving me just 2A is equal to BH. Solving for b means I still have to divide by the h to get rid of the h. So I get 2a over h is equal to b. All right. V equals 1/3 pi r squared h. Again, I've got that fraction. Everything here is being multiplied. So why don't I take care of the fraction first? I can't divide by the fraction, so I multiply by its reciprocal, 3 over 1. That gives me 3v is equal to pi r squared h. Because the 1/3 and 3 over 1 cancel. I want h. Everything here is multiplying by that h. So let's divide by everything there but the h. So we get divide by pi r squared. These two will cancel. Over here, you have to divide by pi r squared here. You're left with 3v over pi r squared is equal to h. There's your final answer. Again, notice how none of these are working out to be a variable equals a number. Not going to happen when you're solving literal equations. All right, we have a squared plus b squared equals c squared. The Pythagorean Theorem. This time we're asked to solve for one of the legs, b. So to do that, we take the formula as it's written, and we start off by asking what's being done to b? Well, it's being squared, and it's having a squared added to it. Exponents come before adding in the order of operations, but we're doing the opposite order. So I'm going to start by subtracting a squared. The opposite of adding a squared, subtracting a squared. These will cancel. You'll be left with b squared is equal to, well, when you go to subtract this, you can't actually subtract c squared and a squared. So you get c squared minus a squared. It stays as part of a formula. Then you have to do the square root to get rid of the square. Opposite operations. Square root of b squared is just plain b. Over here we can't do that square, so it stays as square root of c squared minus a squared. All underneath the square root symbol like that. There's your final answer. Not pretty, but that's your answer. It's also how they come up with the distance formula, but that's another thing altogether. That's actually solving for c. Over here, we got volume equals 1/3 pi r squared h. We've seen this one before, but this time we need to solve for r instead of h. So again, I'm going to start with multiplying by 3 over 1 to get rid of the 1/3. So I have 3v is equal to pi r squared h. This time I'm going to divide by not pi r squared, but pi h to get rid of the h and the pi. So that gives me 3v over pi h is equal to r squared. Last time we were done at this point. When we're solving for h, we were done. Here, we've got a square. So we still have to do the square root to solve from there, which is going to give you the square root of 3v over pi h. This whole thing is underneath the square root. Is equal to r. Hopefully that helps. Try these again on your own. These are very similar equations to what pops up on a lot of these questions that have to do with solving literal equations. So if you stick with just practicing these types solving for the different variables, hopefully you'll get the idea. See you in class.